Today we're going to do two things. We're going to revisit my man crush on Cam Mack and weep for what could have been. And we are going to dip our toes very, very, very gently into machine learning and by looking at something called clustering, which is an algorithm called k-means clustering, and it's based on the idea of k nearest neighbor. That might sound kind of scary, but it really isn't. Think about a scatter plot where you have two dots on the scatter plot. You draw a line between them from point A to point B, and that distance between them is called the Euclidean distance, after the mathematician Euclid. That distance, just that linear distance between them, is a value. It tells you how far apart they are. Well, now imagine thousands of dots on there, and you start to understand that those distances add up, and sort of mean distances between them can be meaningful. What k-means clustering allows us to do is start to build multi-dimensional plots, and the distance between a point in space and a point in another space, and adding those up allows us to start grouping things together. So the point of all of this is, particularly in sports, we try to identify who a particular player's peers are. Well, in this case, we can identify who are the top point guards in college basketball, or top point guards in the Big Ten, who belongs in the same conversation with each other based on their stats. Well, there's a lot of ways to go about doing that, but one of the ways we can do that is by using this clustering. So there is a package called the cluster that you would need to install the sort of normal way. So I'm just going to go ahead and load those up. And because there is some element of this that is random, we need to set a seed here. So that will repeat these things over and over and over again. So I just use 1, 2, 3, 4. You can use whatever you want, just so long as it stays the same. That's just fine. We're going to load up our player data that we've used throughout the season. We now have a complete season to look at. When I did this for the fall semester, we just had 12 games. So I've redone this now with an entire season of Cam Mack to watch, and interestingly, not a lot has changed, but let me show you what is going on. So the first thing we're going to do is we're going to select some stuff from this that we're going to look at guards. So the first thing we're going to do is we're going to get rid of anybody who hasn't played a minute of college basketball this last season. We're going to filter out guards. So we just have guards who actually played. And then we're going to pick from those a set of stats that mean good guard play. So you got player team, the position, which we needed for the filter, minutes played, field goal percentage, 3-point percentage, assists, turnovers, and points. And then we're going to use this NaOmit function, just gets rid of anybody who has nulls anywhere in this data, because null values will make it throw a fit. So we'll just go ahead and run that quick, and now instead of 5,452 observations in the players, we're down to 2,647 guards who actually played a minute of college basketball and don't have null values in any one of these particular fields. So next thing we got to do is k-means clustering doesn't work on any sort of text data. So we're going to create a second data set here that is only numbers. And then what we need to do is we need to put them all on the same basis. So points, let's say points and field goal percentage. One is a fraction and one is a count that can get quite large if you're really, really good. They're wildly different, and so what we need to do is we need to put them all on the same level, and we can do that with a neat little trick here using mutate all. So going back to this, I'm going to take my selected data here that I just created. I'm now going to further select out just the numbers And then I'm going to use mutate all, which does what you think it does. It's going to mutate all of these into a scale, which is exactly what we did with z-scores. So this is going to basically create z-scores for all of these things all at once and overwrite them. And again, we're going to admit any null values because they really do cause a problem. So if I open up player scaled now, you'll see I've got 2,647 observations, same number as player selected of 6 variables. But if you look at it, there's no actual player data attached to it. We don't know who these people are, but every one of these values is now on a sort of a negative, let's call it a -6 to a +6, because I can see some +5s here that in the 3 point. So whoever these people are, they're shooting the lights out with 3-pointers. So now we're at the point where we can actually start doing the k-means clustering. But one thing that we need to figure out is what is the value of k. K is just the number of areas that it's going to search, number of nearest neighbors it's going to look at. So to figure out what the most optimal value of k is, we're going to use something called the elbow method. The elbow method looks at a chart of these, and where it bends like an elbow, that's where you pick your optimal value. So this is a bit of code that I borrowed from the University of Cincinnati's business analytics program. You don't change anything in this, you just run it. And what it is going to do is create this chart. And it's using the sum of squares within the clusters, and where you get a bend like this, where it looks like an elbow, it's sort of flattening out. That's where you want it. So in this case, this would be 4, this would be 5, this would be 6. It looks like the elbow here is at 5. So my ideal number of clusters would be 5. So I'm going to create something called K5, which is indicative of the 5 K things that I'm going to do, and I'm going to run the k-means function on my scaled data. My 5 clusters is what I'm going to do, and this nstart25 is just how many different random seeds it will start with. This is a default value, it doesn't really matter. Just sort of leave it alone and it will be fine. And we'll run K5, and it's created a bunch of values in there, and I'm just going to mute my notifications. So what K5 gets us is just a giant number of vectors, and it will take a little bit of time to show this, but essentially what these numbers are here is the cluster that it decided to put each one of these records into. So you can see a bunch of cluster 1s, here's a 5, a bunch of 2s. What you need to understand is the cluster numbers don't mean anything. It's not a ranking. 1 is not good, 5 is bad. Just that's the number that it assigned to it. What you can do is look at this cluster means area here. So cluster 1 has a -0.85 on the minutes played. If you think of 0 as average, it would mean that cluster 1 played below average numbers of minutes. So it's a cluster mean. So everyone in cluster 1 played a below average number of minutes. They were barely above average field goal shooters. They were barely below average 3-point shooters. They were not great assisters. They were negative, below average turnovers, which I suppose is good, but below average points. So cluster 1 is probably not very good guards. They didn't play a lot. They didn't shoot that well. They were fairly protective of the ball, apparently. But my guess is that they weren't playing very much. They didn't have very many opportunities to do that. All right, cluster 2. Above average minutes played. They were above average shooters. They were above average 3-point shooters, above average assists, but above average turnovers, and above average points, but not much above average. compare that to group 5 here, where significantly above average minutes, slightly above average shooters, significantly above average assists and turnovers and points. So they were above average shooters, but not that much above average. But everywhere else, they're pretty good. Cluster 4, below average, pretty significantly below average minutes, but pretty good field goal shooters, pretty great three-point shooters. Not great with the assists, not probably a lot of opportunities with the turnovers, and way below average points. So that's how you read these cluster means, is it gives you an idea of what type of player you're looking at. And you can look up here with the size of the clusters. So cluster 1 had 863 players in it, cluster 2 989, 3 242, not a lot in cluster 4. That's your way below average shooters, or way below average minutes played, but way above average shooters. I'm guessing these are players that got like 6 minutes and happened to hit every shot that they made, but they didn't stay out on the floor very long. And then cluster 5 has 495 people in it. So just based on the cluster means, cluster 5 is probably the best group here. So what we can do now is we can actually join those back together by creating this data frame that joins these together. So I can go back to my player selected and my K5 cluster, and it's just going to line them up side by side and make a data frame out of them. And when I open up player cluster, and I'll see Darius Quisenberry of Youngstown State, who played 941 minutes, is in cluster 5. If I want to look for Cam Mack, I can just type it up here. And oops, I hit the caps lock. But there he is, played 931 minutes. Not quite a 40% field goal shooter, 33%, 34% really from 3 points. 198 assists, 104 turnovers, 332 points. Put him in cluster 5. So that's the better group. All right. So we can now look at this a little bit more significantly. Let's just go ahead and create a data frame of Cam Mack. There he is in cluster 5. Now we can use our scatter plots to do this again. So I'm going to do minutes played and assists because Mack is going to come out pretty good in those assists. I'm going to color the dots based on the cluster, and you'll be able to see pretty clearly. And then I'm going to make Cam red so he pops out. And there it is. So there's a few different clusters down here, but generally speaking, you're down here, you're in cluster 1. Here's your cluster 2s and 3s. This brighter blue is your cluster 5s up here. Here's Cam Mack for minutes played and assists. So pretty rarefied territory in there. We could do this a bunch of different ways and look at it in a bunch of different aspects, but there's probably cluster 4 here. There's probably cluster 3 here. Here's cluster 1. And here's 5, and you can see how it kind of grouped those together. Why don't they perfectly overlap? Well, you have to remember we used a bunch of different measures to line them up. So this is just looking at minutes played and assists. Points probably move some of these guys around. Turnovers probably move some of these guys around. Things like that. So that's the value of using a clustering algorithm, is it can balance all of these things together and put it in there. So let's just do one little other quick thing. I'm going to filter out the Big Ten. My data doesn't have a conference value, so I've got to do this stuff here. I'm then going to look at who the players in the Big Ten are in cluster 5. So if I filter just Big Ten players, I give you the filter, and I'm going to sort them by minutes played. So who are the good players that played a lot of minutes? Marcus Carr at Minnesota, Anthony Cowan at Maryland, and one Cam Mack. So you'll probably notice several other folks who are probably going to get drafted in here, say Cassius Winston. So yeah, y'all can tease me all you want about how I said Cam Mack was going to be one of the best guards who ever played at Nebraska. I'm not convinced that he's not currently, but he won't be next year, and that's too bad, really. So that's a way to use clustering. It's a way to group players or teams or things like that based on multiple dimensional analysis. And the trick to this all is remembering that these cluster numbers are meaningless. They don't mean anything. It's just a number that it gave to the cluster. It's these cluster means that tell you what kind of cluster that is and who those people are, and you get to make a valued judgment based on these cluster means of which group is the best. Usually it comes out being pretty clear which cluster is the best. In this case, it's cluster 5 when we're talking about guards. The metrics here are pretty clear, except turnovers. But, if you're making a lot of passes, you're making a lot of turnovers. It's just what it is. So that's clustering. It's useful, it's interesting, and it's a dip of a toe into machine learning. If you're still listening to this podcast or to this screencast, there is going to be a class in the spring of 2021 in advanced sports data analysis where we'll do a lot more of this stuff that could be really, really, really interesting. So talk to me if you're interested in that.